So before we start this problem dealing with angular and linear speed, we're going to review what each of these terms mean. So angular speed is the speed at which an arc is swept around a central angle, and linear speed is the speed of a point or the end of the ray that is swept about by the central angle. So the problem we're going to be dealing with is the wheels of a bike have a radius of 3 feet. The wheels rotate at a rate of 400 revolutions per minute, and now we need to find the bike speed in miles per hour. So before we start, we need to convert this 400 revolutions per minute to angular speed. And angular speed is represented by the Greek letter omega, and it equals the central angle in radians represented by theta over t, which equals the time interval. And so we'd have to convert 400 revolutions in 1 minute to radians per minute. And so to do this, you have to multiply by 2 pi radians in over 1 revolution, because there are 2 pi radians in 1 revolution, and we have to get this revolution to cancel out. And in angular speed, it's always going to be in radians, so this would equal 800 pi radians per 1 minute. So this is the angular speed. But to find the bike speed in miles per hour, we need to convert this to linear speed. So linear speed is, the equation for that is the velocity is equal to the radius times the angular speed, because this Greek letter omega is the angular speed as reviewed up here. So we have this as the angular speed, so we'd write this out, 800 pi radians in 1 minute. So we need to multiply this by the radius, and the radius is 3 feet. So let's multiply this by 3 feet, and here we get 2400 pi, this right here, radius, 2400 pi feet per 1 minute. And so here we have the linear speed, but this is feet per minute, and it wants the speed in miles per hour. So we need to convert this to miles per hour. So we need to get everything to cancel out. So let's just start this off with converting feet to miles. And since there are 5,280 feet in 1 mile, we need to multiply this by 1 mile over 5,280 feet. Or in other words, we would be dividing this amount of feet by 5,280. So once we have this, now we have the feet cancel out, but we still need to get the minutes to be converted to hours and have those cancel out. So we know that there are 60 minutes in 1 hour, and so here now we've converted from minutes to hours. So we have the minutes cancel out, and so now we have miles per hour. And whenever you multiply all of this out, you would get 85.680 miles per hour. So your final answer, the bike speed, is 85.680 miles per hour. And yeah, that's a pretty fast bike if you ask me.